Yes, unit step functions. In continuation of our examples on the Laplace transformation, let me consider one more type of the example which is known by even Heaviside function u of t minus a or h of t minus a. Notation is different, but the meaning is same. What is the definition? The unit step function u of t minus a is defined as u of t minus a is equal to 0 when t is less than or is equal to a is equal to 1 when t is greater than a for all a is greater than or equal to 0. Refer here. This is minus infinity. This will be plus infinity. A will come here. Okay, and our Laplace transformation is always behave between 0 to infinity. Is it okay? We are not considering less than 0. I mean the negative values like up to negative infinity we are not considering. Therefore, if the given function is between 0 to a, it will be 1. Otherwise, it is 0. The same has been shown here. Therefore, the Laplace transformation of unit step function is L of u of t minus a. That is what? U is what? The given term, given function, whatever it may be. L of u of t minus a is equal to e to the power minus as divided by a. A has been taken from t minus a under u. Okay, I will take some examples of this type, how to recognize the unit step function. Therefore, next, Heaviside shifting theorem. If L of f of t is equal to f of s, then L of f of t minus a into u of t minus a is equal to e to the power minus as L of f of t. That is e to the power minus as into f of s. That is what? L of f of t is equal to f of s is already known by us. Then L of f of t minus a into u of t minus a. This will be what? If the given function is in this manner, refer here, if the given function is in this manner, then the result will be e to the power minus as into f of s. Then we shall take some restrictions. If we put a is equal to 0 in the result number 1, we get L of f of t u of t because a is equal to 0. Then this term is equal to f of s. F of s is what? Laplace of given function. Observe that L of u of t minus a equal to e to the power minus as divided by s. It is already shown by the definition. Then the third function, if f of t is bifurcated in this manner between 0 to a, f1 of t, I mean the first function, for t is greater than a, f2 of t. Then these two f1 and f2 are connected by the relation f of t is equal to f1 of t plus f2 of t minus f1 of t into h of t minus a. Just note the definition here. I am not giving to give any proof here. While solving the examples, you can recognize how this how this rule will work. Then the same f of t is trifurcated, I mean divided into three terms. For 0 to a1, f1 of t, for a1 to a2, f2 of t, for greater than a2, it will be f3 of t. Then these three functions are connected by the relation f1 of t plus f2 of t minus f1 of t into u of t minus a1 plus f3 of t minus f2 of t into u of t minus a2. Refer, this is very important. When the three functions are given under Heaviside, these three functions are connected by this relation, that is given f of t is expressed in terms of unit step function as u of t minus a or h of t minus a. Now we shall consider one example. Before going to find the examples on the unit step function, I have taken one more example from the for the periodic function of the Laplace function. Let me explain the thing, because this example is taken from one of the old question paper. Find the Laplace transformation of the function. I mean this function is known by half wave rectifier. F of t is equal to e sin omega t between 0 to pi upon omega, pi 0 to pi by omega, and 0 between pi by omega to 2 pi by omega. Then here e and omega are constants. We know that the given function, the periodic with period 2 pi upon omega. Why it is 2 pi upon omega? End point of the given interval. If the given function is bifurcated, then we need to take what is the period? Capital T. Capital T is given by 2 pi upon omega. Therefore, L of f of t is equal to 1 minus 1 upon 1 minus e to the power minus st between 0 to t e to the power minus st f of t dt. My dear students, know the difference between small t and capital T. Capital T is what? Period of the given function. Small t is what? Variable in the given integral. In the integral. Okay. Therefore, substituting respective values. What is t? 2 pi upon omega here. Substituting respective values. Therefore, using the integration and use this formula once again, as we are known in solving examples in the beginning of the Fourier series. Integration of e to the power x sin bx dx equal to e to the power x upon a square plus omega square, it is b square, s square plus b square into a sin bx minus b cos bx. Try to know, one is e to the power x sin bx dx, another is e to the power x cos bx dx. Try to note these two functions. The same has been shown here between 0 to pi upon omega, because the interval is between 0 to pi upon omega. Therefore, substituting the upper and lower limit, take the care while substituting the respective values. E upon, where is that E? E is already shown here. E upon 1 minus 1 upon 1 minus e to the power minus of 2 pi s upon omega into omega e to the power minus s pi upon omega plus 1 divided by s square plus omega square. Refer this substitution correctly and neatly. Okay. What is here? A and B are constants. S is the parameter. Only x is the variable. You need to put x equal to upper and lower limit. Okay. Therefore, it reduces to this solution at the end. Okay. Thank you.